so we've been talking about degrees and radians, and now we're going to use that information along with some of our previous geometry information to start making what's called the unit circle. So our unit circle is kind of like a one-stop shop that gives us a lot of the information that we could possibly need. So we kind of started looking at our unit circle whenever we made that circle with all of our special angles on it. So all of those special angles, they're special angles because we use them quite often. And so we want, on our unit circle, it's going to contain all of our special angles in degrees and radians, and then we need to add one more part to it today. And basically, it's like, so instead of having to memorize each of these things separately, it allows us just to memorize this one thing, and then anytime that we need pretty much any information for our trig stuff, we know that we can find it on our unit circle. Cool? All right. We do need a little background information before we can start kind of adding in the last little pieces of our unit circle information. All right, so who can tell me one of our main three trig functions? Sine. Sine is one of our trig functions. Do you remember any of our other trig functions? Cosine and tangent. So those are our three main trig functions. We actually have three more trig functions that we're going to talk about a little bit later. But those are going to be the three that we're going to talk about and use today. So you have sine, cosine, and tangent. Now, when we're talking about our trig functions, what does trig stand for? Trigonometry. And what does trigonometry mean? It's a big word. Okay. I think it's triangles. Triangles. Okay, yeah. So remember that geometry is the study of shapes. And then trigonometry is kind of like a subset of geometry, and it's specifically the study of triangles. Okay? So when we're talking about sines, cosines, and tangents, we're talking about triangles. Do you remember specifically what type of triangles we're talking about? Right triangles, not the wrong one. Okay, so right triangles means that we have a right angle. Okay. And then what are other pieces of a right triangle? Hypotenuse, okay. How do I know which one's the hypotenuse?
It's opposite from the right angle.
Agreed. It's also our longest one. So this one over here, that is diagonal from our right, is going to be our hypotenuse. Which a way that helps me to remember that is a picture that I saw that it's of like a hippo lying across the leg of that triangle because it's a hippopotamus, right? Your hippo couldn't lie on the straight up and down or the straight across. So it has to lie along the slanted one. So that helps you or not. All right, and then we actually need a reference angle in order to be able to label the other ones. So let's say that this bottom right is our theta. Then we can also label our other two sides. What are they going to be labeled?
Opposite.
Okay, which one's opposite? Okay, so the one directly across from theta is opposite. And then what's this one called? Adjacent. So remember that our sine, cosine, and tangent are functions, and we actually find those functions of an angle using the sides of the triangle. It's a relationship between the sides of the triangle. So in general, our sine is going to be which two sides?
Opposite.
So it's going to be our opposite side divided by our hypotenuse. And then our cosine is our adjacent divided by the hypotenuse, and then our tangent.
Opposite divided by.
Does anybody remember the little saying or yeah? So the little saying that kind of helps us remember it is which stands for sine, opposite hypotenuse, cosine, adjacent hypotenuse, and tangent, which is opposite adjacent. Yes? Okay, so good. Alright, so then remember, we talked about our special angles, and we're going to use those same special angles to then form our special triangles. So, what are our 3 special angles?
30, 45, and 60.
30, 45, and 60 degrees. Okay? Now, the other thing that we need to remember is how many degrees, better word, are in a triangle. 180. So we know that we're wanting to use our 3 special, so 30, 60, and 45. And I also know that I'm looking at right triangles still. So we already know that one of our angles is 90 degrees. So let's use our first one. And let's say if I labeled this as 30 degrees, what do I know that my other angle has to be?
60.
It has to be 60. In order for them to all add up to 180, it would have to be 60. Okay? Likewise, if I labeled either one of these as 45 degrees, what do we know our other angle has to be?
45.
It also has to be 45 degrees. So remember that this is a 30, 60, 90 triangle, and this is a 45, 45, 90 triangle. Okay? Yes? You also did that part. Now, we're going to use these triangles to basically set up our unit circle, because I want you to see where the numbers are coming from, right? I don't want you to just like, oh look, we randomly pulled these numbers from thin air. So we're going to use these formulas and these triangles the first time that we find the information, right? After that, you don't have to use them again. Does that make sense? So like, you don't have to go through this process every single time. We're going to have to memorize our unit circle. And so you can always just use your unit circle. But I do want you to see where all this stuff comes from first, because that gives you a better understanding of like why the unit circle is the way it is. Are you all with me? Okay, so we also need to know our special triangle formulas for the sides, which we should have learned in geometry. Okay, so remember, the easy one for me to remember is the one with 45s, because remember that if I have 2 angles that are the same, we also have to have 2 sides that are the same. And so that one's a little bit easier, because I know that whatever my bottom side is, my other side will also have to be the same. Now we don't know what it is, so we just leave it as x, but we know they have to be the same. And then the other side, or our hypotenuse side, is x square root of 2. So it's whatever number or length that other 2 sides are times the square root of 2. And if you wanted to prove that, what could we do with our first 2 sides in order to find our missing side? What? There's a square root involved. The Pythagorean theorem. So we could do like x squared plus x squared equals our hypotenuse squared, right? And then you would end up having to take the square root. And we have 2x squared. Well, the square root of x squared is x, and then we still have the square root of 2 left over. So that's where we get that third side. We all with me? Now, our other relationship is a little bit different because it's not quite as nice. So I'm going to label our base still as x. That kind of gives us a starting spot. However, whenever we get to here, our height side is going to be x times the square root of 3, which then means that our hypotenuse is going to be 2x. We vaguely remember those formulas from geometry? No? Okay. Well, if this is the first time you've seen these formulas, just know that if I have a special triangle or a triangle with these angles, I can use these formulas to find the sides. And basically, I just have to know the length of one side, and I can find all of the other ones. You know what I think? All right. Now we need to use that information. So I'm going to go ahead and label these angles. So I'm going to say that this first angle is 45 degrees, and this second angle I want to label as 60 degrees. Notice that we also have two right angles because our triangles are perpendicular to our x-axis. So far, so good? All right. Now, like I said, we're trying to set up our unit circle. Now, the big thing about our unit circle, and the reason why it's labeled as a unit, is because our radius is going to be 1. Okay, and that's always true. No matter where you see the unit circle, how you're using the unit circle, we always assume that the radius is 1. Okay? So that means that if we're looking at the unit circle, our center would be at the origin. So that means that anywhere that I were to draw a triangle, yes, my hypotenuse is going to be 1 because the hypotenuse would be the radius. Are y'all with me? Yes? Now, it just so happens that sometimes your x-axis might also line up to be it, but your hypotenuse is always going to be 1. So I'm going to go ahead and label both of these hypotenuses as 1. Now, since both of these are our special triangles, we can use those formulas from the previous page to help us fill in the other two missing sides. Agreed? Yes? All right. So if I know that my hypotenuse is 1, so I have a 45, 90-degree triangle, okay? What was the formula for our hypotenuse? X square root of 2, right? And I know that my other two sides, move that down a little bit, are going to be x. So we need to find out what x is in order to know our other two sides. Are you with me? Mm-hmm. Well, if we know that this equals 1, then what does x have to equal?
Square root of 2 over 2.
Yes. So you kind of skip this step. So it would be 1 divided by the square root of 2. That would divide both sides by the square root of 2. And then, because we don't like to leave square roots in our denominator, we want to rationalize it. So we would multiply the top and the bottom by the square root of 2. Which, so the bottom should just be 2. There we go. Okay, yes? And remember that our formulas were that both of these sides are the same. So both of these are going to be the square root of 2 over 2. Yes? So far, so good? All right, likewise, if we wanted to do the same process for our red triangle, what was our formula for the hypotenuse of a 30, 60, 90 triangle? 2x. And again, we have x's in our other two sides, so we need to know what x is. So I would set that equal to what we have as our hypotenuse. So what do we know that x is? 1/2. Okay. So that tells us that our base is just going to be that 1/2. Yes. And then remember that our height for a 30, 60, 90 is x times the square root of 3. So it would be 1/2 times the square root of 3. Well, what's a nicer way to write that? Square root of 3 over 2. I'm just going to combine them to be one fraction instead. So we have the square root of 3 over 2. So far, so good? Like I said, this is all for the setup, but we're only going to have to do this once. Once we do it once, then we know our answers and we can just use those in the future. So right now, with what we've already covered on our unit circle, we have all of our angles labeled, okay? Which gives us all of our special angles that we might see. However, we also want to label our sines and our cosines. Yes? Which we just reviewed our definition of sine and cosine. So we're going to use these two triangles that we just created to help us find sine and cosine. So remind me, we said that our sine of any angle is going to be what? Opposite over hypotenuse. But what did we say is the nice thing about our unit circle?
Hypotenuse is always 1.
Your hypotenuse is always going to be 1. So what is sine always going to equal?
Opposite over 1.
Yeah, opposite over 1, which is just opposite. Yeah? And we can kind of do the same type of idea for our cosine. Well, cosine of theta is going to be over hypotenuse, but then because our hypotenuse is 1, it's just going to equal our adjacent. We all with me? So then let's go ahead and label. If I was looking for the sine of 45 degrees, we know that it's going to be the opposite side, which is what? 3. And it just so happens our cosine is going to be the adjacent, which is also what? Square root of 2 over 2. Now, for our red one, we would have that sine of 60 degrees is what? 3. And cosine is 1/2. Now, we're actually missing the sines and the cosines for our third special angle, which is 30 degrees. But instead of making another triangle, can we use the information that we have?
Just pretty much.
Yeah, so on our red triangle, notice that this top one would be 30 degrees. So now my opposite and my adjacent have flipped, which means that my sine and my cosine are just going to flip. So we would get 1/2 for our sine. And square root of 3 over 2 for our cosine. Yes? No? Maybe? All right. to do is we want to put this like in an easy way to see on our unit circle. We don't want to write out like sine and cosine for like every single angle, because that gets a little cumbersome. Agree? So notice that each of these has a point. So this would be my point for my 45-degree angle. This would be the point for my 60-degree angle. Yes? Now, how do we usually write a point? X and a Y coordinate. Agreed? So notice that we would have an X and a Y coordinate for both of these points as well. However, if we notice, okay, if this is my point, the base of my triangle, right, which is going across, would be which distance for that point? Your X value, okay? And if this is my base, what side is that also? For my angle that's inside. It's your adjacent. Agreed? Yes? So we can also rewrite this point as adjacent, comma, well, then my height leg, I'm going up and down, right, would be my Y value, and that would give me my opposite side. Well, let's think about the information that we just found. Well, what do we know that sine is always going to be?
Opposite.
Our opposite, and our cosine is always going to be our adjacent. So that means that we could also rewrite this point as cosine of theta, comma, sine of theta. So that means that if we're on our unit circle and we have a point anywhere on our unit circle, that's going to give us our sine and our cosine of the corresponding angle. So instead of having to write sine, cosine for every single angle, we're just going to put a point next to that angle, and that gives us our sine and cosine. Yes? Okay. The only tricky thing is to remember that cosine comes first. So we're used to saying like sine, cosine. So just remember it's in alphabetical order. So your cosine is the first number, your sine is the second number. So let's go ahead and look at our unit circle that we have. So this is the one that we kind of created in our previous notes by labeling all of our special angles in degrees and radians. So remember, our special angles are 30, 45, and 60, but we also want all of the intervals of that as well, all of the multiples of that. So we want the special angles in all four of our quadrants. So that's where we got all of those numbers. And so now we're going to label our ordered pairs for each of those angles. Well, let's just start by looking at the first quadrant. So we just found a second ago our sine and our cosine for 30 degrees. What did we say that our cosine was for 30 degrees? Yes. So it's going to be the square root of 3. That's a really bad 3, so let's fix that. 3 over 2. And then what did we say that our sine was? 1/2. And so this ordered pair tells us that cosine of 30, or pi over 6, is square root of 3 over 2, and sine of 30, or pi over 6, is 1/2. Do you see where I'm getting that from? Like I said, this is just kind of another way of writing our sines and cosines without having to label sine and cosine every single time. All right? So then what did we say that our sine and our cosine were for 45 degrees? Both of them are square root of 2 over 2. So that means that our x and our y are the same for that one. Okay? And then lastly, we said that our sine and our cosine for 60 are the same as our 30. They're just flipped because basically we're using the opposite angle. So we have 1/2, comma, square root of 3 over 2. Now we can actually fill in a little bit more information without having to do any other work. So we know that all of our radiuses are 1. Agreed? Which means that that includes my x-axis and my y-axis. So if from my center to the point that lies on my x-axis is 1, what would that associated point have to be? So I went over 1 on my x-axis, and then I didn't go up or down on my y-axis, so I would get 1, 0. Likewise, for the point that's up at the top on my y-axis, well, I went up my y-axis 1, and I didn't go anywhere on my x-axis, so what would that point be?
0.
0, 1. So those give us our sine and our cosine for 0 or 360 or 0 or 2 pi and 90 or pi over 2. Okay? We all with me so far? Okay. Now it's going to take a little bit of finagling in order to find our last remaining coordinates. So notice that here I drew my first triangle in my quadrant 1. I drew my second triangle in my quadrant 2, right? But even if I were to reflect this triangle over, right, it's still the same triangle. All my lengths and my angles stay the same. Does that make sense? So it doesn't matter what quadrant we're in as far as how we draw the triangle. The only difference is, notice that is this 60-degree angle in standard position? No, because remember that we said a angle in standard position has to go from the positive x-axis to the terminal side. Agreed? So if we wanted to label this red triangle with the angle in standard position, what angle would that be? How'd we get that?
180 minus 6.
Agreed. So like the whole from the positive x to the negative x-axis would be 180. I know that the portion inside of my red triangle is 60, so that means that the leftover piece would be 120 degrees, which tells us that my 120-degree angle is going to have the same values as my 60-degree angle, which means that my ordered pair, or my sine and my cosine, are also going to have the same values. So basically what we're going to do is we're just going to copy and say, well, I know that 120 is going to have the same ordered pair as my 60-degree, so I just write 1/2, comma, square root of 3 over 2. The only difference is, because now we're to the left of our y-axis, what does that do to the sine SIGN?
X turns negative.
Yes, it makes our x negative. You okay with that? So then kind of using the same thinking, if we were to draw a triangle for our 135-degree angle, we would get that, correct? We know that this angle right here is the one that's 135. But as far as the triangle goes, in order to be able to find our sines and cosines, we would need to use this angle. So what would that angle be? Excuse me. Yeah, we know that that has to be a 45-degree angle, because basically that's what's left over to get us to 180. So what does that tell us as far as our coordinate points go?
It's the same as yellow.
The other one being which one?
The other 45.
The other 45. So we know that our point is going to be the same as our 45 degree. So we would get square root of 2 over 2, comma square root of 2 over 2. But what's going to be the only difference? The x is going to be negative. And then lastly, if we were to make a triangle with 150, what would we get for it?
The same as the 32 but make them negative.
Yep. So it's basically going to be what we got for 120, but flip our x and our y.
But keep the negative in the same spot.
Agreed. Now we can kind of use the same thinking that we did over on the other side. This time, if I'm going to the left 1 unit, what is this point going to be at?
-1.
Okay. And we want to use the same type of logic for our third and fourth quadrant. The only difference is going to be whenever I start making my triangles, we want to make sure that we're still using our x-axis. So I still want to draw my triangle to the x-axis. I don't want to draw my triangle to the y-axis. So now we know that 210 would have the same triangle as what angle? 30, because we know that we've gone 30 degrees past 180, which tells us that we would have the same triangle as 30 degrees. But this time, which one's going to be negative? Both of them. Okay. So then, what is the angle going to be for the triangle for our 225?
Same as 45, but
Root of negative square root of 2 over 2. Okay. And then lastly, the 240 would have agree. Okay. And then kind of using the same thinking, since we've gone down this time 1 unit for 270, what would its point be?
0.
All right. So now I want you to turn and talk with your neighbor and decide what your points would be for your last 3 angles. Okay, so we decided that our 300 is going to be the same as a what?
60,
Agreed. So that means that it's going to be
1/2 negative square root of 3 over 2.
agreed. So 1/2 comma negative square root of 3 over 2, because this time our y values are going to be negative. Our 7 pi over 4 is going to be the same as,
So, square root over 2.
yes, comma,
negative square root of 2.
And then lastly,
730 square root of 3 over 2. Negative 1/2.
and we don't need to find 330 or 2 pi because it's going to be the same as our 0. So y'all with me? All right, and like I said, now that we've figured out how to find all of those with their special angles, we don't have to do that every single time. We just need to memorize this unit circle. Now, really, the only thing we need to memorize, though, is our first quadrant. Because then remember in our video from there, we talked about how to find all of our other angles by adding 90 or adding 180, right? And then we just talked about once I have my ordered pairs for each of these, we can find all of the other ordered pairs. So memorizing that first quadrant and then just making sure you know how to find all of the other ones. Are we all with me? Now I will tell you that we will be using this unit circle basically for the next 3 chapters. Okay, it's really important that we know it, know how to use it, and can recreate it. So because of that, we're gonna have a quiz over our unit circle at the end of next week. So we'll do practice tomorrow, practice on Monday, and then we're gonna have a quiz over it next week. And I always get 1 or 2 students that just refuse to memorize it. And then usually, like 1 or 2 chapters in, they go, this stuff is really hard. Why is everyone able to do this so much faster and easier than I am? And it's because everybody else knows the unit circle and they don't. So trust me when I tell you that this is going to come up again and again and again and again. So we really, really need to know how to use it and how to find all of our values on it.